So we said that the two-stage model assumes that the change between the growth rate in the short term and the growth rate in the long term happens overnight. So the H model comes in order to make this transformation between the two growth rates linear, so that the calculation would assume that this change does not happen overnight, but happens gradually. And therefore the formula that we use in order to calculate value in this case would be equal to, it's a slight variation of what we took. It would be equal to D0, which is the current dividend, multiplied by 1 plus GL over R minus GL. And this is the first part. This part is the value that we get from the normal growth period. The part of value we get from the normal growth period. Now we need the part that we get from the high growth period, and that would be D0 times H into GS minus GL. So as I said, this part would then be the part of the value that comes from the high growth period. And what we mean by H is the H is usually half the high growth period. So if my growth period is 4, my H would be 2. If my high growth period is 4, my H would be 2. And therefore I deduce that the higher my H is, the higher the high growth periods, the bigger the value that I'm having. But the result that we get is not really very accurate. The longer the high growth periods, the longer they extend, and the bigger the difference between the long term and the short term. Sorry, the short term minus the long term, because the short term is bigger. Then the less accurate the value I'm calculating would be. Now let's take a numerical example. So the example says that we have a stock which has a price of $120. The most recent dividend is $3. The short-term growth rate is 20%. The long-term is 6%. The growth period is 10 years, so half of the growth period is 5. And we have R, which is the required return, is 10%. So let's calculate the value of this stock. D0 is $3. So I start with $3 here, multiplied by 1 plus 6%, and then I add to that 3 times H, which is 5, and the difference between the high growth rate and the long-term growth rate, which is 6%. I divide all of that by R, and R is 10%. Minus GL is 6%, and the number that I get is 79.5 plus 52.5 which is equal to $132. Note that the 79.5 is the first term divided by the denominator, and therefore it's the part of the total value that of the 132, which is the total value that comes from the normal growth period, which is the long term. But this part over here is the second term and gives me 52.5, which is the value, the part of this 132 that comes from the high growth period. So after valuing my stock, I find that it's $132, which is less than the price in the market, that is $120. Therefore, this stock is undervalued, and it might be a good indicator for me to go and buy this stock because it's undervalued. One last thing I want to say is that I could rearrange this formula, assume that assume that V0 is equal to the price in the market, and solve for the implied rate of return. So plugging P instead of V, I multiply by R minus GL and I left by the numerator. Then I will have, if I keep rearranging the terms, I will have R to be equal to D0 over P0. So I factor the D0 here, and therefore I'll have D0 over P0 multiplied by 1 plus GL plus H into GS minus GL and here it was R minus G, so the G has to be added at the end of this term here, GL. Plugging in the numbers I had from the previous exercise, I will get 10.4%. So I'm gonna put, I'm gonna let you put down the given so that you could plug in the numbers and make sure that you get 10.4% if you do. This means that the answer 10.4% is greater than the 10% we used, which means that the market believes that the stock is riskier than it actually is, and this explains the lower price, the price that is lower than the value, which has led to the undervaluation of the stock. So this is it for this video. I hope you like it. If you do, please subscribe to my channel. I'll see you in the next one. Bye bye.